Hello everyone. So today we're going to be looking at the questions from the Chapter 7 assessment. So let's get started. For number 1, they want us to find all the characteristics of the following function. So let's go ahead and find the x-intercept first. Remember that the x-intercept is when the graph crosses the x-axis, which means that you want to set y equal to 0. So let's do that down here. So y in this case is f of x, so we're going to set that to 0. Now you want to go ahead and solve this equation. So you want to get rid of the 4, so you want to subtract 4 on both sides. Alright, remember that you need to move the x minus 3 over, and it's dividing because of the fraction bar here. So you need to multiply both sides by x minus 3. So you need to use a distributive property here. So you got negative 4x, and then negative 3 and negative 4. Give you positive 12. You got 5 on the right side. Now you need to solve. Subtract 12 on both sides. Now you need to go ahead and divide both sides by negative 4. Two negatives is a positive, so it looks like you have 7 over 4. Next, you want to find the y-intercept. So we want to set our x to 0 in the original. So we have here y equals 5 over 0 minus 3 plus 4. Now we just got to do the math here. So we got a fraction plus a whole number. Alright, so we have negative 5/3. And we have a 4 over 1. So we got two fractions that we got to combine. Our least common denominator is 3, so we need to multiply this by 3 in order to make it into a 3. Whatever we do on bottom, we do on top here. So we have negative 5 over 3 plus 12 over 3. And then we have negative 5 plus 12 is 7, so we have 7 over 3. And that is our y-intercept, so we're going to plug that in. Now let's look at the vertical asymptote. So remember, the vertical asymptote is when you want to set the denominator to 0. So here in this example, the denominator is x minus 3. So we're going to go ahead and set that to 0. And the only value that makes this 0 is going to be x equals 3. And that's our vertical asymptote. Alright, in order to find the horizontal asymptote, you're going to use the rule for rational functions of the following form. So normally this form follows the format of a over x minus h plus k, or y equals that. So now that we know that they match, then if you know that the horizontal asymptote is given by the k value, then you can go ahead and easily identify that here. So in this case, the k value is 4, so my horizontal asymptote y equals 4. Alright, pretty simple to find the HA as long as you have this form right here. Alright, so now let's go ahead and do the domain. The domain are the set of x values that exist that can be plugged into the function without any errors whatsoever. So in this case, we can plug in any value for x except for the vertical asymptote. So therefore, x cannot equal to 3. The range is a set of y values that can be plugged into the function, or that can be outputted from the function, rather. In this case, the only value that we cannot have is 4 for the horizontal asymptote. So we're going to go ahead and say y cannot equal to 4. As long as it does not cross that horizontal asymptote, then y cannot equal to 4. There are some scenarios where it can be equal to 4 where it crosses, but this is not one of those cases. Okay. So now we have to find the end behavior. In order to find the end behavior, you're going to use the following template. Remember that you want to look at the left and the right ends. So if you look at the right end of the function, which is positive infinity, you need to observe what happens to the y. In order to do this, you're going to use the horizontal asymptote to help you out. So as x goes bigger and bigger in the positive direction, the graph is supposed to approach the horizontal asymptote, which is 4. And as x goes becomes more negative in the left side, then you're still going to be approaching the horizontal asymptote at 4, and you'll be able to see this when we actually draw the graph. As far as the transformation is concerned, you're going to be using this form in order to identify how much it shifts, or you can use the vertical asymptote and horizontal asymptote to help you out. In this case, h is 3 and k is 4. That's telling me that it's shifting to the right 3 and up 4. So shifts right 3, up 4. Alright, and you can always draw the graph if you don't remember how to do this, and it should lead you to the right answer, because normally it'll tell you can kind of tell if it's shifting right or left or up from the graph. Alright, so let's go ahead and graph our x-intercept, or our x-intercept is 7 over 4. This is 4 goes into 7 once, and then you have a remainder of 3 over 4. So this is almost 2. 7 over 3, 3 goes into 7 twice, with a remainder of 1, so 1 over 3. So this is over 2. So let's go ahead and graph these two. So we have 1 and 3/4 is pretty close to 2. 2 and 1/3 is a little over 2. We got our vertical asymptote x equals 3. Go ahead and draw that the best we can. And then we're going to draw our horizontal asymptote at 4. Now we're going to go ahead and look at both sides of the vertical asymptote. So we're going to look at the left side, and we're going to look at the right side. So on the left side, you can tell that it's crossing these two, and it's going to be approaching this asymptote right here, and it's going to be approaching this asymptote on the right side. So we're going to go ahead and draw the curve that illustrates that fact. So I'm going to try to draw this the best we can. So it's trying to approach that asymptote but never actually reach it. And that takes care of our left side. Now we need to look at our right side here. Notice that we don't have any points on the right side, so this is where we're going to start plugging in some points. So I'm going to plug in like 4 into the function, the x value 4, since that is to the right of 3. So if I plug in 4, I get f of 4 equals, so I'm plugging in 4 for x here, and x into the function. So we have 5 over 4 minus 3 plus 4. So 4 minus 3 is 1, so we have 5 divided by 1 plus 4. That's just going to be 5. 5 plus 4 is 9. So when x is 4, y is equal to 9. So 4 and then 9. That's telling me that it's above the horizontal asymptote, which means that it's going to be approaching it from the top. And it's going to be approaching the vertical asymptote on the other side here. So we're going to try to draw that the best we can. So there's that part, trying to approach this vertical asymptote. And then this guy is going to be approaching, try that again. Going to be approaching that from the other side. Alright, and there's our graph, and normally this point right here, this in the middle, is right here on the origin. Normally, but then now we can tell it's shifted to the right 3 and up 4. So therefore the transformation seems to make sense here. It shifted right 3 up 4. Now we're going to take a look at 2. And we're going to repeat the process. So let's do the x-intercept. Again, that's when it crosses the x-axis, which means y is 0. So we're going to set f of x to 0. Alright, we're interested in getting rid of that denominator. So to get rid of a denominator, you're going to need to multiply by it. Whatever you do on one side, you have to do on the other side. So we're multiplying here. 0 times anything is 0. One of the wonderful properties of 0. These cancel, and leaves you with x plus 7 on the right side. Now we can go ahead and proceed to solve this for x by subtracting on both sides. So we got x equals negative 7. I'm going to plug that in here. Now let's find our y-intercept. So remember, the y-intercept is when x is equal to 0. So we have y equals 0 plus 7 over 2 times 0 minus 8. 0 plus 7 is 7. 2 times 0 is 0, so we have 0 minus 8. Alright, so then it looks like we have 7 over negative 8. And that's the same thing as negative 7 over 8. So here it doesn't matter if the negative is in the bottom or the top or on the outside. It's still the same fraction. It's still negative. So that's our y-intercept. Alright, now let's go ahead and find our vertical asymptote. Remember, that is when the denominator is equal to 0. So we're going to set the denominator equal to 0 down here, 2x minus 8. So we're going to add 8 to both sides. So we have 2x is equal to 8. Go ahead and divide both sides by 2. So you have x equal to 4. Alright, at this point you want to find the horizontal asymptote. So in order to find the horizontal asymptote, you got to look at the different categories, if you will, for the horizontal asymptote. Okay, so I'm going to discuss those 3 categories here so that we can apply that in this problem and the next problem. Okay, so let's talk about those properties. So let's look at horizontal asymptote category 1. So let's look at these guys. So for the first category, if the degree of the numerator is greater than the degree of the denominator, so if degree of numerator is, let's do the less than first. So if the degree of numerator is less than the degree of the denominator, then that implies that your horizontal asymptote is going to be y equals 0. The second case is if the degrees are equal, that means that you're going to take the ratio of the leading coefficients, and that's going to be your A over C. So I'll write out how that would look like. So if, for example, your function was f of x equals ax plus b over cx plus d, then you're going to take, and these powers are the same, so in this case these powers are the same, then you're going to take the ratio of the coefficients of the highest power for the x. So in this case it's a over c. So that's how you would do that. So if this were like a 1x and this were a 2x, then this would be 1 over 2. And that's if the degrees are the same. Remember that the degree is the highest power of x. Alright, now let's look at the third case. If degrees are, if the degree of numerator is greater than degree of denominator, that means you have no horizontal asymptote, which means you have to find slant asymptote. Etc. Okay, so now that we know those cases, let's see what this case belongs to. So if you look at the following problem, you have x plus 7 over 2x minus 8, which means that the powers are 1. So if you look at the power here, the power for x is 1, the power for x is 1, so the degrees are the same. That means you're going to take the ratio of the leading coefficients. So there's an invisible 1 there and a 2 there. So that means it's going to be 1 over 2. And that's going to be your horizontal asymptote, y equals 1 over 2. Now let's go ahead and look at the domain. So the domain cannot be the vertical asymptote. So the domain are the x values that cannot be crossed or that cannot be used into the function. So that's going to be 4 because that's our vertical asymptote. Our range cannot be the values given by the horizontal asymptote, generally speaking. So our range, y does not equal to 1/2. For our end behavior, we're going to use the following template. Remember, as x approaches, as x gets bigger and bigger on the right side, the graph is trying to approach the horizontal asymptote at 1/2. Same thing on the left side. If it's getting larger and larger, if it's growing more negative, then the graph is still approaching horizontal asymptote at 1/2. As far as transformation is concerned, for this guy, you can either graph it or you can convert it and then find the transformation. One way of doing this without doing either of those two is to look at the asymptotes. So you notice that the asymptote x is equal to 4 and horizontal y equals 1/2. That's telling me that it's shifting right by 4 and shifting up by 1/2, because this is a positive 4 and this is a positive 1/2 for y. So you can kind of tell from the asymptotes what it's going to be. So shift right 4, up 1/2. Now we're going to go ahead and do the conversion. So in order to do the conversion, we need to do a long division of this function. So we need to do x plus 7 divided by 2x minus 8. So that's our original function, and we need to go ahead and do a long division. So it's x plus 7 divided by 2x minus 8. So we need to figure out how many times does 2 go into 1. In that case, it's going to be 1/2, because 1/2 times 2 is 1, and there's an invisible 1 right here. So now 1/2 times 2x is 1x. 1/2 times -8 is -4. Now we're going to go ahead and subtract. Now since we're subtracting, we can go ahead and flip the signs here. So I'm going to go ahead and flip this sign here to negative, flip this sign to positive, and then go ahead and do the result. So this is going to be 11. So this is our remainder. Remember that you always put the remainder over the original denominator. So this guy becomes 1/2 plus 11 over 2x minus 8. Remember that we're trying to match this to a over x minus h plus k. So right now you can kind of tell that the k is 1/2. So what I'm going to do is I'm going to move the 1/2 over to the right side. So it matches up more nice. So now this is 1/2. You can tell that's the second number there. It's on the outside. Now notice that there's a 2 here and an invisible 1 here. That needs to be a 1 in order for it to match. So we're going to divide both sides by 2. So both numbers by 2, but whatever we do on the bottom, we have to do on top. So I got to divide this by 2. So it leaves me with 11 over 2 over 1x minus 4 plus 1/2. Now we can tell that's our k, and that's our h. So we're already matched up with the graph, so that is our conversion. So it looks like we have, and I'll do this in another color, 11 over 2 over x minus 4 plus 1/2. So now notice that in this case, it's shifting right by 4, which is what we said, and it's shifting up 1/2, which is exactly what we said in transformation. Now let's go ahead and graph this. Right, so let's go ahead and graph our vertical asymptote. So x is equal to 4. Alright, now let's do 1/2. Y equals 1/2. That's below 1, so we need to be careful with this. Now we have x equals -7 for the x-intercept. That's where it crosses the x-axis right there. Y equals -7 over 8. That is actually that's actually between -1 and 0. So that's like over here. It's pretty close to -1. Alright, so it looks like we have everything we need for the left side. You can kind of tell that the left side wants to approach here and then wants to curve down towards this vertical asymptote. So we can go ahead and draw that graph now. Try to draw the best we can. Should look more, it should be approaching this more, so let me try that again. Okay, and then get that to approach here. There you go. Alright, so it doesn't actually touch or cross, it's just approaching it. And now we need to do the right side, so we need to plug in a number to the right of this vertical asymptote. Remember, this vertical asymptote is at 4, so we need to plug in like 5 or 6 or something like that. So let's plug in 5 into the original. So we have here, let's do it down here, f of 5 equal 5 plus 7 over 2 times 5 minus 8. So we have 5 plus 7 is 12. 2 times 5 is 10. 10 minus 8 is going to be 2. 12 divided by 2 is 6. So we have 5 and then 6. Now we can kind of tell how it looks like. It's curving up here and then curving down to the horizontal asymptote. And there's our graph. So now we're going to do number 3. So we're going to do the same thing, find the x-intercept first. So x-intercept, set y to 0. So we're going to move the x squared minus 3x minus 4 onto the other side by multiplying. So that'll be 0 on the left side equals x plus 3 minus 3 on both sides. X is negative 3. Now let's do the y-intercept. We're going to set x equal to 0 there. So we have y equals 0 plus 3 over 0 squared minus 3 times 0 minus 4. These are both going to be 0, so you have 0 minus 4, which is negative 4. So you have negative 3 over 4. Now let's do our vertical asymptote. Oops. So vertical asymptote is when the denominator equal to 0. So the denominator is x squared minus 3x minus 4. So we're going to go ahead and factor this since it is a quadratic. So factors of negative 4 that add up to negative 3. The only numbers that work are negative 4 and 1. So this is going to be x minus 4, x plus 1 equal to 0. So that means x is equal to 4 and negative 1. Because 4 minus 4 is 0, negative 1 plus 1 is 0. And we want to get 0 for both of them so that this equals 0. Alright, so that's a vertical asymptote for negative 1. We have 2 of them. Now we need to find the horizontal asymptote. So I'm going to go ahead and rewrite the function so that I can show you the powers. Remember that the degree of this guy is the highest power. So there's an invisible 1 there. So the degree here is 1. Highest power here is 2. So degree is 2. So degree of numerator is less than degree of denominator. So this is case 1. So therefore y is equal to 0 for my horizontal asymptote. Alright, now let's do our domain. So domain is where x is equal to or not equal to. So in this case, x cannot equal to any of the vertical asymptotes, so 4 and negative 1. Now for the range, you need to determine whether the graph can actually cross. So if you put y cannot equal to 0 and then you find that it crosses, then go ahead and change that. However, in order to determine if it actually crosses the horizontal asymptote, because remember the rule. So the rule is that vertical asymptotes are never crossed, and horizontal asymptotes sometimes crossed. You can never cross a vertical asymptote because you can never divide by 0, and the horizontal asymptote is sometimes crossed. So in this case, in order to determine if it crosses, what you're going to do is you're going to plug in 0, which is the horizontal asymptote, into the function. Okay, so we're going to do that, and that'll tell us if it crosses. If it does cross, that means that we have all real numbers for the range. Okay, so let's go ahead and do that. In fact, we actually already did that now that I think about it, because we already plugged in 0 in when we found the x-intercept. Remember the x-intercept was when y equal to 0? And we already plugged that in when we did x-intercept. And we got an x value of -3. And that's telling me that it does cross the horizontal asymptote at -3. And therefore you do have all real numbers here. You do have -3. So in this case, y would be all real numbers. And you show that with the symbol right here, all real numbers. This is something that we haven't really looked at too much. So if you did put y cannot equal to 0, I didn't count against you. It's just something that I forgot to elaborate on. So if you did put that y cannot equal to 0, I didn't count against you. Alright, so now let's go ahead and do the end behavior. So the end behavior is as x approaches infinity, y approaches. So in this case, you're going to be approaching the horizontal asymptote, which is 0. As x approaches -infinity, y approaches the horizontal, which is 0 again. In this example, transformations, there's no need to do a transformation. It's a graph in and of itself. It doesn't follow any of the forms. So this is not applicable. You can only do the transformations in general for the original parent function, which is the simple rational function, and this is a more complex generic rational function. So not applicable there. Alright, so now we're going to go ahead and graph this. So we have -3 as our x-intercept. -3/4 is a little bit above -1. Vertical asymptotes 4. And -1. Make sure I did that right, because it looks a little bit off, so I want to make sure that I got this correct. Yep, looks like we got 4 and -1, so it looks fine. Alright, so now y equals to 0, which is the x-axis in this case, which, as we can tell, it crosses right there. Alright, so now let's go ahead and do the graph. So we're going to need, since it does cross the x-axis here, right, and it does cross the horizontal asymptote, we're going to need more graphs for more points for this function, because we need to know if it behaves like this, where it approaches from that side, or we need to know if it behaves like that, or if it behaves more like that, where it crosses but then it approaches it from the other side. Because either way, it's going to be approaching from the other side. The only issue is, like, does it cross from the top or does it cross from the bottom? Okay, so we need to be able to determine which one of those is true. So we need to plug in points. So let's plug in -2 into the original. So let's do x is equal to -2. So I'm going to do like a xy table here. So let's do -2. Let's do -5. And then I'm going to do some points here, okay? So on the middle side, so in the middle, we need to know if this behaves like this, or if it behaves like this, or if it behaves like that. My guess is that it's going to behave like a U because it doesn't. We are not crossing the horizontal asymptote except at -3. But the more points you have, the better. So we're going to go ahead and put in the other points. So let's do 2, just to be safe. And then now let's do on the right side. So let's pick like 1 point on the right side. Does it behave like this, or does it behave like that? So we need to figure out what side it's on. So let's put 5 to figure that out. The next thing I'm going to do before I plug stuff in, I'm going to rewrite the original function in terms of its factored form. So we said that we factored the bottom. Okay, so let me rewrite that down here so I can show you guys. So we're going to rewrite the function. This is the original function. And we're going to rewrite that with the denominator factored. Alright, so now we're going to go ahead and plug into the factored form because it's easier to do it that way. Okay, so now let's plug in -2. So f of -2 equals -2 plus 3 over -2 minus 4, -2 plus 1. So -2 plus 3 is 1, -2 minus 4 is -6, -2 plus 1 is -1. Go ahead and multiply the bottom. -6 times -1 is 6. So it looks like we have 1 over 6. Now let's do -5. So f of -5. -5 plus 3 over -5 minus 4, -5 plus 1. So this is going to be -2. -5 minus 4 is -9. -5 plus 1, -4. -9 times -4 is 36. So this reduces to -1 over 18. Just divide both sides by 2. Now let's plug in 2 and 5. So we have 2 plus 3 over 2 minus 4, 2 plus 1. 2 plus 3 is 5. That's going to be -2. 2 minus 4 is -2. 2 plus 1 is 3. 3 times 2 is negative. 3 times -2 is -6. So we have -5 over 6. Now let's plug in 5. 5 plus 3 over 5 minus 4 times 5 plus 1. 8 over 1 times 6. So you have 8 over 6, which reduces to 4 over 3. So we have -5 over 6 and 4 over 3. Alright, so let's go ahead and plot those points now. So let me zoom in on that for you guys. Okay, so we have -2 and 1 over 6. So -2 and a little bit above that. That's telling me that it's starting up here. It's starting from on top and then crossing and then approaching from the other side. That's what that's telling me. So, and then -5 is going to be -1 over 18, which is really small. So now we can kind of tell that this is approaching. I'm going to try to do this the best I can. Approaching from there, up there. It crosses and then approaches from the other side. So it's trying to approach the horizontal asymptote, but from the other side because it crossed. Now let's do this part, 2 and negative 5 over 6. And we have 5 and 4 over 3. 4 over 3 is 1 1/3. So a little bit over 1. Okay, so this part it does the U. So it looks like it's trying to approach here. Approaching there. And then this guy is trying to approach here and here. Alright, and there's your graph. So it looks pretty complicated. Because you have the two vertical asymptotes. Alright, now let's look at these choices here, 4 through 7. Now I crossed out number 7 because we're not looking at number 7, and that is because this graph does not match up with it. So we are not looking at this graph. So the other 3 graphs match up just fine, but this one does not match up. So therefore I tossed that question out. So now let's look at number 4. So again, if you look at number 4, you want to look at the denominator in order to find the vertical asymptote. You want to set that to 0. So now let's factor that. So you want to find the factors of negative 4 that add up to 0 because there is no middle term. The only numbers that work are 2 and negative 2. So you have x minus 2, x plus 2 equal to 0. What makes the x minus 2 0? It's just going to be 2. 2 minus 2 is 0. What makes x plus 2 0? Negative 2, because negative 2 plus 2 is 0. So therefore we have 2 vertical asymptotes. The only one that has that is B. So if you look at B, this is kind of similar to the graph that we did earlier. So this would be B. So our explanation is that it has 2 vertical asymptotes, and the horizontal asymptote for this guy is y equal to 0 because the degree of numerator is less than the degree of denominator. Now let's look at number 5. If we look at the vertical asymptote, we want to set the denominator to 0, solve, move the 2 over. So you have x squared equals negative 2. In order to get rid of the x squared, we need to do the square root. But you cannot take the square root of negative 2, and therefore this cannot work. So there is no vertical asymptote. So there is none. The only one that follows this, where you have none, is C. So C has no vertical asymptote at all. And if you look at the horizontal asymptote, this follows case 2, where the degrees are the same because they are both 2. Therefore you do A over C, which is 1 over 1, and this gives you y equal to 1, which makes sense because this is my horizontal asymptote at y equals 1, and there is no vertical asymptote for C. So therefore C belongs to number 5. If we look at number 6, we have a vertical asymptote at x equals to 2 because 2 minus 2 is 0. And we have a horizontal asymptote at y equal to 3 because of that k value. Therefore, the graph looks like where it's shifted 2 to the right and 1, 2, 3 up, which is exactly this guy. So it's going to be D. Now it is not A because A, notice that the graph is going up here and then down here. It has to start out going down, and then it has to start out dipping down, like going from left to right, going down, and then like this. It has to go like this because this is how normally that's how it looks like. It doesn't normally look like that. Okay, so that would be D. Alright guys, I hope this was useful. Go ahead and do your corrections and explain this in words in order to make up for the test or get a curve bump. Have a good day guys.